For our second class exercise, we're going to build a calculator class that we can use to compute simple arithmetic, such as addition, subtraction, multiplication, and division. So we'll begin by defining the class calculator, and then we'll open the body. This particular class will not have any private data. All we want the calculator to do is take in two operands, two numbers, and an operator, and then compute the result. So all we need is a public section for this class. Our first function will be add. It takes two double operands, op1, op2, and it returns op1 plus op2. Let's put a space here just to make it a little bit easier to read. Our second function is subtract, which we'll call sub. Again, two operands. Return op1 minus op2. Double mult for multiply. Op1 again and op2. Return op1 times op2. And then finally double divide, div. Double op1, double op2. Return op1 divided by op2. Now the function that drives everything will be our calc function. It will take the two operands as well as the char operator, and then it will look at the operator, decide what operator it is, and then call the correct function based on that, like so. So else if op equals minus, return sub op1 op2, else if op equals asterisk or star, then return mult op1 op2, else if op equals slash / then return div op1 op2. And that's all we need. So we close off the definition. Come down to our main program. Declare the calculator. Now notice that we don't have a constructor, but the compiler implicitly calls a default constructor, although in this case there's nothing to do at all. But we still have to declare an instance of the class. Then we need some variables, op1 and op2. We need an operator variable, op, which is char. And then we'll use the old while true trick again because we can't parse. We don't know how to parse in this course. So it's really hard to make our calculator quit based on a character because we can't do any parsing. So what we'll do is we're going to write out a prompt. This time we're going to use a little greater than sign as a prompt. We're going to get in the first operand, followed by the operator, then the second operand. Then we're going to write out a call to calc, c.calc, with op1, op2, and the operand as our arguments. Then we'll write a new line, and that should be all we need. So let's build and run the program. 2 plus 2 is 4. 4 times 4 is 16. 16 divided by 2.3 is 6.95652. 7 times 2.2 is 15.4. And 15.4 or 15.3 minus 16 equals negative 0.7. To close the calculator, we simply hit Control-C. With the calculator built as a class, we can plug this code in any situation. So in a command line situation that we have here, we can run it just like it is. Of course, it'd be better if we had some parsing capabilities than we would if this were an advanced course. If we had a graphical user interface, we could use this, where we simply got this operand from a text box. Then the user would click a key, and that would get stored into the operator variable. And then the user would type in another number, and that would be stored in op2. Then we'd write it out to another text box or wherever it is we're supposed to put it. So rather than a cout, we'd have the output going to the correct place. The point is that by putting the class code or making it available to the graphical user interface program, and then putting a call to the calculator correctly in the right place in the code, we can use this in that type of program as well as in a command line program like we're doing here. That's one of the greatest advantages of creating classes, is the reusability and flexibility you have with your programs. That's going to be the last exercise for this chapter. And in the next chapter, we're going to look at an important topic in object-oriented programming, and that's operator overloading.